The AI Vulnerability Storm. The Cloud Security Alliance has published an updated Mythos document, a complete risk register, priority action table, and board briefing template for CCSOs who need to walk into a room Monday morning with a plan. The AI Vulnerability Storm doesn't waste time on whether AI-driven vulnerability discovery is real. That argument ended when Mozilla reported 271 Firefox bugs found by Mythos 3 warranting CVs, and when Moke demonstrated autonomous exploit generation against 98% of open-source KEVs using publicly available frontier models. Instead, the paper focuses on the structural asymmetry. AI compresses the disclosure-to-weaponization timeline to hours, while defenders still operate on quarterly patch cycles. The paper introduces VulnOps as a permanent organizational function, staffed and automated like DevOps, but for continuous zero-day discovery and remediation across an organization's entire software estate. The 12-item risk register maps each threat to OWASP LLM 2025, OWASP Agentic 2026, MITRE ATLAS, and NIST CSF 2.0 controls, with honest acknowledgments of where frameworks don't yet cover the new threat landscape. The most pointed recommendation: formalize AI agent usage across all security functions immediately with mandatory security controls. Without agents, most tasks on this list will be untenable, the paper states. But they must be defended. The agent harness itself. Prompts, tool definitions, retrieval pipelines, escalation logic, is called out as the new attack surface requiring the same audit rigor as the agent's permissions. The paper draws a direct comparison to Y2K, a systemic threat with a hard deadline that the industry met through coordinated, disciplined effort. 10 diagnostic questions help CCSOs gauge their actual security posture, from whether employees can use agentic coding tools today to whether executive leadership has a working definition of urgency. Meanwhile, a hands-on demonstration of defense in depth arrived via CVE2026. 31431 known as copy fail. The vulnerability exploits a flaw in the Linux kernel's AFALG cryptographic API, where a race condition in the ed_scatter/gather implementation allows an unprivileged user to corrupt the page cache and overwrite arbitrary binaries, specifically by sending crafted data through Authentizen Hamaksha 256, CBCS, and using Splice to deposit shellcode directly into cached pages of /u/s/s/bin/su. A researcher at GNOME's GitLab infrastructure ran the full exploit chain inside a rootless podman container and traced the kernel's response with eBPF. The result: set to its zero return success inside the user namespace, but container root mapped to UID 1000 on the host. An unprivileged user. The exploit achieved full privilege escalation within the namespace boundary, and none of it mattered outside. One important caveat: the page cache is shared across the host, so containers reusing the same base image layers could execute poisoned binaries. A cross-container isolation break that never requires escaping to the host. For production environments, the researcher recommends enabling user namespace support for OpenShift Pods GA since 4.20 and investigating ephemeral microvms via Cloud Hypervisor for CI/CD workloads. Agentic Coding Matures. The agentic coding community has largely settled the whether question and moved deep into how. Drew Brunig's 10 Lessons for Agentic Coding distills the emerging consensus into durable guidelines that should survive at least a few model generations. The headline insight: code is cheap, but maintenance, support, and security aren't. When implementation costs approach zero, the bottleneck shifts to judgment. Knowing which code to write, maintaining behavioral contracts through tests that measure what a product does rather than how it does it, and keeping specs in sync as living documents rather than frozen artifacts. Lesson 9 captures the hidden advantage of experienced developers. They bring intuition to their prompts. The right terms, the right framing, the right level of specificity, saving countless cycles during both implementation and debugging. Pair that technical expertise with great taste, Brunig argues, and you have an unbeatable advantage. That intuition is increasingly being codified into layered architectures. Claude Code's multi-stage agentic system illustrates the pattern. Claude.md files serve as persistent organizational memory and constitution. Skills provide modular on-demand expertise database migration, security review, Rust optimization. Hooks add deterministic guardrails around events like file writes and tool calls, and subagents operate as specialized delegated reasoning units with bounded scope and isolated context. The result, as Reuven Cohen describes it, is a layered cognitive stack where memory, expertise, governance, delegation, and execution are separated into composable primitives. It starts looking less like a single model responding to prompts and more like a coordinated engineering organization. The details matter at every layer. Claude Code versions 2, 1, 1.2.4 and 2, 1, 1.2.6 reveal the fine-grained tuning happening inside the harness. A new system reminder tells the agent when a file was modified, but the diff was omitted due to budget constraints, directing it to reread if needed. A small fix that prevents wasted tokens from stale content. More revealing is the removal of a reminder that asked agents to consider whether each file read might be malware, a guardrail apparently deemed more noisy than useful. As agentic sessions grow longer and more autonomous, observability becomes critical. Argus, a new open-source VS Code extension, provides timeline visualization of tool calls, cost tracking, and context usage across Claude Code sessions. Addressing what one commenter called an underrated need for comparing whether an agent actually improved across runs or just got lucky once. The agent autonomy gap. The Unhyped AI newsletter published a carefully argued essay on what may be the most subtle risk in the current AI moment: the ease with which AI can automate the appearance of strategy without producing the thing itself. A real strategy document does not merely sound convincing. It carries choice, exclusion, and a theory of consequence, writes the author. The piece identifies a second-order problem worth naming. AI-polished strategy documents make disagreement harder to start. When someone hands you a rough draft with obvious gaps, you argue with it. When someone hands you a polished document with no visible seams, the social cost of saying this is wrong goes up. The prose quality becomes armor. The essay isn't anti-AI. It endorses using AI to gather threads, test framings, surface angles, clear undergrowth, but draws a hard line between aiding thought and counterfeiting it. The serpent has not merely eaten its tail. It has offered to draft the governance memo about the meal. The autonomy gap extends well beyond strategy documents into the entire consumer agent landscape. A detailed analysis of current agent products identifies what it calls the anticipation gap, the distance between agents that can act and agents that know when to act without being asked. The core observation: coding agents succeed because they have clean verification tests pass or fail, bounded scope fix this bug, and cheap iteration. Consumer life has none of that. Did the agent book the right flight? How do you define right? There's not a compiler for taste. The proposed framework is a 5-step permission ladder: read, suggest, draft, act with confirmation, and act autonomously. Most consumer agents are stuck at step 1, and products that try to jump to step 5 without earning trust fail badly. Symphony, OpenAI's open-source orchestration protocol, was born because engineers had fast coding agents, but people were still opening their sessions and assigning tasks and checking progress and nudging agents. Even sophisticated users are hitting human attention bottlenecks. Anthropic's Project Deal experiment offers a controlled test of what happens when agents negotiate on behalf of humans. The company created an internal marketplace where Claude bought, sold, and negotiated for employees, and found that more intelligent models sold items at higher prices. The community reaction was predictably split. One camp sees the dystopian future of personalized price gouging at scale. Another points out that airlines have been doing dynamic pricing with ML for years. And a third notes the experiment had a sample size of one with questionable math. How did they sell the same bike twice? The gap between agent capability and trustworthy autonomy is also visible in content generation. A Reddit post documenting 45 seconds of Facebook confidently attributing the White House shooter as a former staffer of nearly every major sports team illustrates how generated content passes through platforms at scale without verification. The AI citing AI feedback loop producing confidently wrong fabrications at industrial speed. The local inference arms race. AMD's leaked Ryzen AI Max plus 495 Gorgon Halo APU pushes unified memory to 192 GB, enough to load models that previously required multi-GPU rigs, but the community response is measured. Memory bandwidth appears to remain at 256 GB/s, theoretical measured at roughly 180 GB/s in llama.cp on current Strix Halo hardware, and the RDNA3 iGPU's compute efficiency tops out around 62% of theoretical FP16T FLOPS. As one commenter who has done extensive kernel work on RDNA3 notes, at long context, compute is actually what's killing decode speed. While the AMD APUs remain on RDNA3, this won't change. The consensus is to wait for 2027's Medusa Halo, which may move to a 384-bit LPDDR6 bus in RDNA5, addressing both bandwidth and compute efficiency simultaneously. For those running NVIDIA consumer hardware today, the Club 3090 repository has emerged as a definitive community resource. It provides validated Docker Compose configs, benchmark scripts, and multi-engine support VLLM, llama.c, pp, sglang for serving models like Q, WEN3, .627B on 1 or 2 RTX 3090s. The dual-card VLLM configuration hits 127 tokens per second with DF flash drafting, while llama.c, PP on a single card handles the full 262K context window without prefill cliffs at roughly 21 TPS. The repo's stress testing suite, including a 7-check boundary case stress test and multi-turn agent traffic soak test, reflects hobbyist infrastructure that now rivals production-grade serving setups. Tensor parallelism is finally arriving in llama.cpp, and the benchmarks show why it matters. Running Mistral Medium 3.5 128 BIQ4XS, 62.5 GB across 4 RTX 3080 20GB cards. Tensor Parallel Mode delivers 21.6 tokens/sec versus 10.4 with layer splitting, a clean 2x improvement for generation. The MOE model Quen 3.5122BA10B tells a different story. Tensor Parallel actually slightly decreases generation speed because expert routing doesn't benefit from the same cross-card parallelism. VLLM still wins for throughput-oriented MOE serving, hitting 187 TOC/S output with 8-way concurrency. An even more radical approach decouples attention from weights entirely, splitting the attention layers a couple of gigabytes onto one machine and the weight matrices onto another, effectively bypassing the memory wall for local LLM inference. Early experiments with Gemma 426B using this architecture show functional results, with a working implementation available in the Larkle repository.
Small models, big ideas. A developer has built a second thoughts system that attaches a small transformer sidecar to a language model, reading output near the end of generation and feeding refined representations back near the top as a refinement loop. Inspired by neuroscience findings about bidirectional processing in the brain documented in the Repeat Yourself, research on how humans reread their own writing to improve it, the system dramatically improved a 1.7B model's coding performance on the first 20 human evil problems. The mini LLM runs a standard forward pass on the deep representation, transforming it from what the model nearly output into what the early layer should have built. The community is particularly interested in whether a second pass yields further improvement or whether, as one commenter puts it, the model stops fixing real bugs and starts inventing new ones to justify another pass. Results on QWEN3.59B are forthcoming. Sculpt takes a different approach to squeezing more from less, a plug-and-play open-source pruning tool that shapes models to specific workloads rather than optimizing for general benchmarks. Born from work on biologically inspired co-activation algorithms for expert placement on chips, Sculpt analyzes how a model responds to a given workload, identifies the parts that aren't necessary for that specific use case, and produces a standard Hugging Face checkpoint compatible with VLLM, llama.cpp, GGUF, and Llama. No runtime changes required. The author sees the technique as especially relevant for robotics, sensors, and other local-first applications where smaller, faster, less consumption is the future. For those who want to run multiple specialized models concurrently, a project demonstrates 4 LLM agents with per-agent LoRa adapters sharing a single RTX 3078 GB, a striking demonstration of operational density on consumer hardware. And for anyone trying to understand what's actually inside these architectures, HF Viewer provides interactive visualizations of Hugging Face models. Paste a URL and get a granularity adjustable diagram that makes architectural differences between model families visible at a glance. Scaling the infrastructure stack, Communications of the ACM surveys the road to billion-token context windows, a goal that NVIDIA's Rubin CPX architecture is explicitly designed to enable by 2030. The article surfaces the gap between advertised and effective context. The advertised context window is largely a memory-bound definition, not a quality-bound one, says Ayush Goyal of Vesa. As context grows, the KV cache overwhelms memory bandwidth, forcing serving stacks to page state to cheaper tiers like CPU or NVMe, adding latency variance and quality hits. The attention dilution problem, spreading fixed attention over ever more tokens, degrades signal to noise until vast stretches of context become what Bob Gorley of Odo calls context rot. Rubin CPX attacks this with an inference-first design, disaggregated GDDR7 memory paths optimized for context ingestion, separated from token generation. But experts note the billion-token target will likely require algorithmic breakthroughs, state space models, test time training, or recursive language models, alongside hardware. The realistic future, as Goyal frames it, is not a single flat attention window, but hierarchical attention combined with retrieval and compression. OpenAI's engineering team published the architecture behind their low-latency voice AI infrastructure, serving over 900 million weekly active users. The core insight: standard WebRTC's one-port per session model doesn't fit Kubernetes at scale. Their solution splits the system into a stateless relay, lightweight UDP forwarding with a small public footprint, and a stateful transceiver that owns all WebRTC session state ICE, DTLS, SRTP. The relay reads just enough packet metadata, specifically the ICE username fragment, encoded with routing hints during signaling, to forward first packets to the correct transceiver without any external lookup.
The implementation uses Go with SOAR, EUSEPORT, for kernel-level packet distribution across workers, LockOS thread for CPU pinning, and pre-allocated buffers to minimize GC pressure. If a relay restarts, the next UN packet rebuilds the root from the UFrag hint. Combined with Cloudflare geosteering, Global Relay shortens the first client to open AI hop by entering traffic at a nearby edge point. The broader lesson: the best place to add complexity is in a thin routing layer, not in every back-end service or in custom client behavior.
Physics meets computation. MIT engineers have built a computational violin that produces realistic sound from first principles. No samples, no averaging over thousands of recorded notes. The team imported CT scans of a 1715 Stradivarius into a solid modeling program, divided the instrument and surrounding air into millions of finite elements, and applied physics-based equations of stress, motion, and acoustic wave propagation to simulate how each material element interacts with every other. The result: plucked string pizzicato renditions of Bach's Fugue in G minor and Daisy Bell, a nod to the first song ever produced by computer-synthesized voice, that emerge entirely from the physics of vibrating strings, wood resonance, and air coupling. The practical application is for luthiers. Tweak the backplate thickness or change the wood type and hear the difference before carving a single part. We're not saying that we can reproduce the artisan's magic, says Professor Nicholas Macris. We're just trying to understand the physics of violin sound. The model currently handles pizzicato only. Bowing involves far more complex string bow friction dynamics, but the team says this physics-based foundation could eventually be paired with a bowing model for full violin simulation. On the neural side of creative generation, Lightrix has released LTX2.322 BICLAR, AHDR, a 22 billion parameter video generation model fine-tuned with LoRa for HDR aesthetic output, continuing the trend of parameter-efficient adaptation producing specialized creative tools from general-purpose foundations.